The binomial theorem provides a way to expand the expression a plus b to the power of n, where n is a non-negative integer. Notice that the power of a decreases by 1 in each term, while the power of b increases by 1 in each term, and that the sum of the powers of a and b in each term is always n. The coefficients c0, c1, c2, and up to cn are the numbers in row n of Pascal's triangle. To construct Pascal's triangle, begin with 1 at the top of the triangle. This is row 0. The next row has 2 ones. For each new row, begin and end with 1, and each number in between is the sum of the two numbers directly above it in the previous row. So we start with 1, add the numbers above to get 2, then end with 1. Next row, start with 1 again. Add the numbers above to get 3, 3, and end with 1. Go on to the next row, starting with 1, adding the numbers above to get 4, 6, 4, then 1. You can go on and on. The row numbers start from 0 at the top. How do we apply these numbers? If the binomial is raised to a 0 power, then it simply equals 1. If it's raised to the first power, then look at row number 1 in Pascal's triangle. We get coefficients 1 and 1. If it's raised to the second power, then look at row number 2. The coefficients are 1, 2, and 1. If raised to the third power, look at row number 3. The coefficients are 1, 3, 3, and 1. And you can continue. Notice once again that the exponent of a decreases while the exponent of b increases, and the sum of the exponents in each term equals n, which is the power the binomial is raised to. Let's expand this binomial. Refer to the Pascal's triangle. Since the binomial is raised to the fourth power, we look at row number 4, giving us the coefficients 1, 4, 6, 4, and 1. Here, a is x squared and b is y. The first term will have the coefficient 1, and x squared is raised to the fourth power, while y is raised to nothing, which means it's just 1, so we can skip it. In subsequent terms, the exponents of x squared decreases, and the exponent of y increases by 1. The second term has the coefficient 4. X squared is raised to the third power, and y is raised to the first power. The third term has the coefficient 6, and x squared is raised to the second power, and y is also raised to the second power. The fourth term has the coefficient 4, with x squared raised to the power of 1, and y raised to the third power. Finally, the last term has the coefficient 1, where y is raised to the fourth power, and x squared is no longer present, as it's raised to the power of 0. Let's simplify using the rules of exponents. Remember, when a power is raised to a power, we multiply the exponents. The first term is x to the power of 8. The second term is 4x to the power of 6y. The third term is 6x to the fourth power y squared. The fourth term is 4x squared y cubed. And the fifth term is y to the fourth power. Since these terms have different exponents, there are no like terms to combine. Therefore, this is the fully expanded and simplified expression. Here's another example. Since the binomial is raised to the fifth power, we use row number 5 of Pascal's triangle for the coefficients 1, 5, 10, 10, 5, and 1. For the first term, the coefficient is 1, and 2x is raised to the fifth power. In the following term, the power of 2x will decrease and the power of 3 will increase by 1. The next term has the coefficient 5, and 2x is raised to the fourth power and 3 to the power of 1. The third term has the coefficient 10, where 2x is raised to the third power and 3 raised to the second power. As you go, check that the sum of the exponents in each term is 5. The fourth term has the coefficient 10, where 2x is raised to the second power and 3 is raised to the third power. The fifth term has the coefficient 5, where 2x is raised to the first power and 3 raised to the fourth power. Finally, the sixth term has the coefficient 1, where 2x is no longer present and 3 is raised to the fifth power. Let's simplify each term using the rules of exponents. For the first term, we raise each factor inside the parentheses to the fifth power, so we get 32x to the fifth power. For the second term, 2x raised to the fourth power is 16x to the fourth power. The third term, 2x cubed equals 8x cubed, and 3 squared equals 9. The fourth term, 2x squared equals 4x squared, and 3 cubed equals 27. The fifth term, 3 to the fourth power equals 81. The sixth term, 3 to the power of 5 equals 243. Let's simplify it further by multiplying all the numerical factors. The first term remains 32x to the fifth power. The second term, 5 times 16 times 3 equals 240. The third term, 10 times 8 times 9 equals 720. The fourth term, 10 times 4 times 27 equals 1080. The fifth term, 5 times 2 times 81 equals 810. The sixth term remains 243. Therefore, this is the fully expanded and simplified expression.